We have a very exciting session now. Please be seated down. Settle down fast. Coordinators, please take care. Make some noise. Make some noise for Sri D.K. Singh ji. Make some noise. That's Josh. Sri D.K. Singh is a distinguished scientist, currently director of the Human Space Flight Center, ISRO, Bengaluru. He holds Master of Technology in Electronics Engineering from IIT BHU, Varanasi. Over his 36 years long association with ISRO, he held a multitude of important responsibilities, including Group Director, Radio Frequency Systems Group, Deputy Director, Human Space Flight and Advanced Technology Area, and Associate Director at the Space Application Center, Ahmedabad. His expertise in its domain of circuits and system design and development for satellite communications and navigation. He made notable contributions in broad spectrum of technical and managerial roles, ranging from the subsystem designer to system designer, project manager to associate project director for ISRO's communication and navigation satellites, starting from INSAT 2 series in 1989 to advanced communication satellites of today, as well as NAVIC series of satellites. I request a very big round of applause to Mr. D.K. Singh ji.
Hello, hello. Hello everyone. बोलो जय भारत, जय विज्ञान, जय भारत. I'm not able to hear you. Okay, so are you ready? So Shubhanshu Shukla has already told many things about his journey to space. In my presentation, I will try to give you some more insights. First of all, let me compliment Naresh Indian ji, a true Indian who brought all of you together here. And when I entered this particular hall, I found this atmosphere is charged. But all of you are charged particle. And when the particle is stationary, it can only attract or repel. So it is our duty to keep you in the motion so that you can electrify India. Are you ready? Okay. So let us start. Can I go to the next slide? Anybody can tell what is this? Where are we in this picture? Not even a dot, right? And all of us carry very big egos. So I always put this slide as a first slide, that let us not consider ourselves above nature. This is universe and our place is very, very tiny dot. You cannot even figure out in this picture. All right. So this vast universe, it challenges us. Come on, explore me. What is there? So that is the curiosity which humankind carries. Next. So let us talk about, we are talking about placing human in space. As Shubhanshu said, it is not easy. There are many things which has to be done. So let us first see what is the first challenge. You have to go to space. Do you know about space? Is it a very nice place, right? Cozy, calm. Am I right? Let us see what is space. Deep vacuum. You cannot breathe. No air. No effect of gravity. Okay, our body, as he said, our body is tuned to 1G, but there is no effect there. Extreme temperatures, extreme cold or extreme hot, depending on are you facing the sun or not facing the sun. Next, radiation, charged particles, debris which we are creating, and probably Chiranjeevi, who is sitting in the front row, is going to clear it. So the space is unforgiving place, and we need to develop the technologies to go there and sustain. That is the challenge. Next. So in this slide, we have been building the satellites and rockets. They all are machines. Even if they fail, I don't care. The moment human comes into the loop, the game is different. So, one by one. So there are risks. So as I said, deep vacuum. So you will get choked if you don't design it properly. Next, extreme temperatures. You will be roasted. Next, extreme cold. You will be frozen. You may get lost in the space. It is infinite. When you land on a planet, you may get crushed and never come back. When you land on the ocean, while coming back, you may get lost in the sea. So these are the top level challenges which we have to address while we are designing the systems for human space flight. Next slide. So these are few more challenges which I am trying to present in the cartoon form so that you can remember. So microgravity, as Shubhanshu said, that lose the sense of orientation, and there are many other effects. Radiation exposure can lead to the cancer, the close environment, fire risk, the toilet. We are lucky here we can use the toilet in 1G. In zero gravity, it is a very different challenge. Okay, fine. So in nutshell, since we are sending human body, the body itself is the biggest challenge. So this chart shows what part of body gets affected due to the space exposure. Now, I couldn't find anything, any important part other than this, which is not getting affected. So all the important parts are getting affected. So you have to take care of those. Next. So it is a tough job, right? Still want to go there? Yes or no? Yes. Then next, let us discuss why and how. So first of all, why at all I should go there? When I painted a very, very scary picture that so many risks are there, what do you gain? So the first thing, probably this goes well with Karnakar Reddy ji also, that the planet Earth, we think that this is our home. We all are spoiling it, and it can never be our home forever. That is first point. Next. Now left side is a beautiful Earth which we have been living. Right side is our future if you don't behave responsibly. I expect people will behave responsibly, but if they don't behave, the right side is right there. Next. This is the risk which nobody can tell it will happen or not. All of you know why dinosaurs got extinct? Anybody can tell? So something hit Earth. What is the guarantee it will not hit again? Okay, next. Now this is man-made. This is the picture of nuclear explosion. And we are such a fool that we have created the nuclear arsenal to destroy the Earth at least 1,000 times. One time is enough, but still we have nukes to destroy it 1,000 times. And if this happens, would you like Indians to get extinct? Yes or no? Indians should not get extinct. So what you have to do? Next. Okay, one more point. Even nothing of this sort happens, there is another risk. So about sun, do you know everything about sun? Let us see. So it is the nearest planet, it gives energy, because of that life is there on the Earth. photosynthesis happen, all other food gets produced. Next, we worship because it's a god of energy. Next, but whether this energy will be there forever? Yes or no? Yes or no? So, next, what happens when this sun gets exhausted? Next slide. So, today there is a green belt. This is receiving the right amount of heat so that this is habitable. So, this is called habitable zone of our solar system. Next, please. As sun ends towards the end of life, it will swell. It is going to swallow first two planets, Mercury and Venus. And it will heat the Earth and Mars in such a way that no form of life can exist. And the Jupiter and Saturn, they will be in the habitable zone, maybe 0.5 billion years or so. So, this is the biggest reason we should start developing the technology to go outside the Earth, find some other place, develop the means to stay there and flourish our civilization and our Indian genes. Next. So, human exploration, when we talk about space exploration, there is always a debate. Can we go with the robots or humans are really required? Next, please. Next. So, these are the two options. Only robots, only humans. But answer is not given by me. Do you know Stephen Hawking? These are the words said by him. If the human race is to continue for another million years, we need to have to boldly go where no one has gone before. This is the challenge. That is why we are going to space. We are developing technologies for humans. They can go in space and live. Next. Now, this slide I will skip. Just go ahead. So, when you want to go to space, first thing, anywhere if you want to go, you need a vehicle, right? Car, bus, bike, scooter. So, for space, you can go only using rockets. Next. Next. So, many people ask, why can't I use aeroplane? A big fuel tank keep on going up. But the aeroplane works only in the atmosphere because it uses the oxygen of atmosphere with the fuel. And it really needs something. So rocket carries its own fuel and its own oxidizer. And it is more than 40 times faster than a normal aeroplane. Next, please. Next. So, once you have the rocket, where will you go? That is the place called orbit. The Shubhanshu Shukla went to a orbit which is about 400 km above Earth's surface and 51.5 degree inclination. So if you need to reach such orbits, what is involved? So if you throw a ball in the horizontal direction, it travels and falls down. And if you throw it faster, it will go further. Just keep on playing. No. So, last 4 picture shows, if I keep on throwing it faster and faster, there will be one point when it will start orbiting the Earth. That is why orbit is created. But, how fast I have to throw? That is the big question. So, I will take you to those who passed the 10th grade, they will know this equation, and they have not passed, they will read this equation. Just go ahead. So this is the first equation. S is equal to ut plus half gt square. So in the 1 second, a ball is going to fall by 5 meters, right? So if I can throw a ball, it's such a speed that if it falls 5 meters, the Earth also should go down by 5 meters. That is where the geometry of Earth comes into the picture. So the above picture shows that if you move around 8 kilometers, travel around 8 kilometers, the Earth curvature goes down by 5 meters. So if I throw a ball at 8 kilometer per second. So I will keep falling, but I will never hit the earth. So that is why Shubhanshu Shukla reached at that speed of 8 kilometer per second, which is around 28,500 kilometer per hour. That is the orbital velocity. Next. So, in nutshell, when we are in orbit, we are actually falling towards Earth continuously, but never reaching the Earth. So this is the basic principle. So now let us go to the real business. So there are three types of space travel. One is near our home planet, which is International Space Station type of thing. The other is people are talking about moon. Then the third destination is Mars and beyond. So short duration, medium duration and long duration. So that is the kind of missions human space flight is moving. Next. So now you will go to the Indian human space flight program. Next. Next. What this picture shows, what is that? A cycle, rocket, a man carrying the rocket, one Indian scientist carrying the rocket. So now friends, today the time has come when rocket will carry the Indian. So that is the mission Gaganyaan. Next please. So how we started? So we have not started overnight. The work on this particular technology was going on for the years. Right from the 2007 with a small space recovery capsule experiment was done. 2014 we have been developing the heavier launch vehicle and a re-entry experiment was done. The pad abort test was done. With all this, the government got confidence that yes, now India is ready for our own full-fledged human spaceflight program. That is when the Prime Minister in 2018 declared that Gaganyaan, just go back, it is important, last two lines. We will launch from the Indian soil, bring them on Indian vehicle, in the Indian capsule, bring them back at the predetermined location in the Indian water and recover. One beta or beti, and you can be one of them. Okay. So, but these two lines creates huge job for lakhs of people. Lot of questions has to be answered, lot of technologies have to be developed. It is not a simple task. Next please. So this shows the roadmap of India human spaceflight program. First is Gaganyaan, which is currently on. This is like if you want to developing the capability to go to the orbit and come back. That is Gaganyaan. Then the Bharatiya Space Station will build up. We are already working on the first module. And that module is like you go there, stay for some time, do some experiment, understand all the technologies and the aspect of long-term human stay in the orbit, and then come back. And beyond that, we have to go to the moon, land there and come back safely. So the moon mission is currently in the design phase. Gaganyaan mission is in the realization phase. Bharatiya Space Station also is in the advanced design phase. Next please. So now this slide shows what is the gamut of technology which is required. So you need a rocket which gives you safe access to the space, a very safe vehicle you need. You need a capsule which can give you Earth-like atmosphere, a breathable air, comfortable temperature, and all those things has to be there. Then you need a orbital module on the left side, which is capable of taking care of all the needs of machines and man when you are orbiting the Earth. Then you have to develop the technologies so that you can, Shubhanshu Shukla was telling that it becomes the fireball. So how do you deal with the fireball when it is coming back? Then after landing, there is a vast ocean. You have to recover them safely within 24 to 48 hours. You cannot afford that a long 7 days, 10 days they are in the ocean. it is not possible to survive. Next. So this is the typical mission profile. So from the Sriharikota, the astronauts will be sitting on the top on a 640-ton vehicle, out of which almost 500 tons are explosive, 500 tons of fuel loaded there. So that is the kind of explosives vehicles they sit on. It lifts off. As a routine, the stage separation takes place. Finally, the orbital module gets injected at around 400 kilometer orbit. After completing the mission, we apply some kind of braking by flipping the module, firing the thrusters, and then this whole module goes into a very, very fiery and scary journey towards the Earth. So at some time around 170 kilometer, we will be separating the service module, which is the aft back side, and only crew module, which is a protected capsule, that will re-enter. So the atmosphere is really a boon for us, and it gives us the capability to do the braking with the practical fuel and that kind of capability. But same time, it heats up because of the friction. So there is always a balancing which has to be done. So it should not get heated too much, and it should receive enough amount of aero braking. When we reach about 60 kilometer, we throw away the apex cover, and then around 7 to 2.5 kilometer window. In that window, the main parachute opens, and the touchdown happens with 8 meter per second. So from 8 kilometer per second to 8 meter per second, that is the journey you have to do, and that is the kind of technology you have to develop. Next, please. Just go ahead. So this is just the zoomed view of the vehicle. It looks slightly different from the other rockets. Why? Because on the top, instead of a regular cover, we have put a crew escape system. So since the human life is always to be protected, so the design is in any mission phase, if some anomaly happens, I should be able to extract the crew module and take it to the safe distance. And as I said, the 640-ton elephant is there on the bottom, but only few tons of ant, cheetah, that is the rocket which is on the top, takes away the crew module and beats the elephant. That is how you save the crew when the mission is happening. Next. This I will just skip. The left side is the regular vehicle, right side is the vehicle where the crew will be taken. Only difference is this vehicle is human rated. So it is safety precaution is there, more redundancy is there, margins are more, and that is how these, and lot of tests has to be conducted. Next, please. This I already talked about, that this is the different phases of the launch. Lift off phase, booster separation phase, then the crew escape system, if it is not used, has to be thrown away. Then the service module, that bottom portion fairings get separated. Then the last liquid stays separated, then the cryo stage fires, and then orbital module gets separated. So these are the typical launch events. Next, please. These are the different kind of crew escape scenarios. Like right at the launch pad, emergency can come. If you are in the atmospheric flight region, the emergency may come. So for all that things, onboard systems are designed. There are onboard computers, they only will take decision based on what is going on, and they quickly separate the vehicle. Next, please. Now this is the most important part. And the upper portion is called crew module, lower portion is called service module. As I said, they are launched together as a single module, but when they are coming back, they get separated. That is why I gave title, Going Together, Coming Alone. So the upper side, it provides the pressurized, habitable, comfortable temperature. Now this is where the spin-off comes. Now there we have to manage all these systems with minimum energy. The water also has to be recycled, not in this module. But in the space station, the long duration missions, every resource has to be recycled. So the ideally space is targeting for 100% recycling. Now imagine if such a technology gets developed because of the space missions, what kind of implication it has on our life here. So that is why the space missions give lot of things to our normal life. Next please. So what is, how do we maintain the habitable atmosphere inside? So there are three type of system. One is to control the pressure, other is to control the humidity and temperature, and third is to maintain the carbon dioxide and oxygen levels within the acceptable limits. Now these are the new technologies which ISRO is developing. Next please. There are other things like thermal protection system. So there are tiles, not the bathroom tiles, the tiles which are designed to burn and dissipate all the heat loads which is coming during the atmospheric re-entry. So different type of tiles has to be developed, and everything has to be glued on the outside of the module. The crew seat, that has to be designed in such a way that it takes all the shock when there is a touchdown happening at 8 meters per second. That is also around 30 kilometers per hour kind of bump. So that is also not a very safe thing. Then the crew module, when it goes into the water, the automatic inflation should happen so that it is always upright and astronauts can come out. Otherwise, if it flips, then it is very difficult to recover the crew. The viewports, the Shubhanshu could show you all the pictures of the space only because such kind of viewports are available in the different space station as well as in the Crew Dragon or our Gaganyaan. So this is a quartz window. So it also can withstand 600 degree kind of temperature, and it should be robust enough that it doesn't get punctured because of the hits. The parachutes also are very important. There are series of parachutes which are used, and typically 30 meter diameter 3 parachutes. They will be used to deaccelerate the final thing. Otherwise, the impact velocity will not be acceptable for the last site is the micrometeoroid and orbital debris. That is a great threat, and recently the Chinese capsule that got hit because of this particular thing. So that also has to be designed. It is like designing a bulletproof jacket for the astronauts, which has to be kept at the strategic location around the vehicle. So that is the kind of technology which has to go in. Next please. Space suit. Now the space suit, what do you say? It is why astronauts are wearing a space suit when they are inside the capsule? I am telling that the air is breathable, pressure is normal. So the space suit is a lifeboat for the astronaut. If they are in the cabin and sudden depressurization happens, this is the one, it will save them and give them enough time to come back to the earth. And it is not a simple technology, it has to take care of multiple aspects. So there are space suits which are worn when they are going up and down, and there is a space suit which is called extravehicular suit when people go out of the space station. And there will be a third kind of suit when the people go on the surface of a planet, like a lunar or Mars. So this technology itself, now this technology has the office shoot on the earth also, when the people working in the dangerous atmosphere, people working at the very high altitude. And actually this is initiated from the pilots in the 1930s. For them the flight suit was being developed, and that has evolved into the space suit. Next please. Next. Sorry, go back. So there we are also developing the fire detection, fire suppression system. The food and water management has to be there. The space food also is a very, very tricky affair. You cannot drink water with the normal glass. It will just float. You cannot eat food with the spoon just like that we are eating here. We are blessed that there is a gravity here. So that has to be packed very differently. Crew health has to be monitored remotely, and any problem is coming, you should come to know. Recently from the International Space Station, the 4 people had to come back premature only because the health was getting monitored from the earth, and they could get the alert that this person is not fit for continuing, bring back. So those are the kind of technologies which we are developing. Next please. Thermal protection. So when you are coming from the International Space Station, you can hit a velocity of 2800 kilometer at the time of re-entry. But when you are coming from the moon, you are free falling from 4 lakh kilometer. That is the kind of thing. So the velocities when you hit the atmosphere, despite of all your orbital maneuvering, everything, it is 45,000 kilometer per second. So with that velocity when you hit the atmosphere, and the atmosphere, we think that the atmosphere is only 10 kilometer, 15 kilometer, 20 kilometer. But the gas densities even at the 500 kilometer is enough to create the drag, and at the 150 kilometer to 100 kilometer is enough to create the fireball if you are hitting at this velocity. And you have to hit at the right angle, otherwise you can go off or you can crash. Next please. The parachutes. So for a successful mission, launch has to be successful, orbital insertion has to be successful, the module should be able to come towards Earth successfully. But if the parachute doesn't deploy, it is a guaranteed death. So to deploy the parachute, some 20 sequence events happens, timed in the millisecond accuracy, and if any of that you miss, you are gone. So what I am trying to make the point that the things are so critical that you have to go through a very, very elaborate design reviews and test program to prove everything before you put a man in the capsule. Next please. The communication. If I take the cell phone from all of you, how long you can survive? So we also make the means for 24/7 connectivity to the crew module. And I just want to share one incident with all of you. One fine day, I received a call, a US number. I did not respond. Later on, voice recorder, one astronaut from International Space Station was calling me, who was my friend. So he can just pick his cell phone from the space station and call anybody on the Earth. So that is the kind of communication system it has to be deployed on such missions. Next please. Once you go into the water, you should have the means of locating where all the capsule has landed. If, see, in the mission design you can always do a prediction, but that prediction can be as off as 100 kilometers. That is too vast for a quick recovery operation. So we have the different location ads like GNSS receivers. There are beacons who will transmit its position. Then there are visual flashes like in the ambulance. So it will keep on flashing. So if some ship or aircraft is nearby, they can locate. So with all these things, the rescue team can reach to the crew module and recover the crew module as well as astronaut. Next please. Now, the recovery is not a simple job. The ocean is wide. Nominal scenarios, only 3 or 4 are nominal scenarios. But there are 50, 60 non-nominal scenarios. So, you have to develop a lot of coordination, involve all the national agency, and really ISRO is thankful that this is a national mission. All the agencies are part and parcel of this particular mission, and they are helping us to do the recovery operation. Next please. Next. So after they come back, they are isolated for some time, primarily because of 2 reasons. One is their health may not be, they have to adapt again, because from the 1G to 0G again back to 1G. In between they have felt 4G, 5G, 6G also. So many Gs. So their body gets confused. So they have to get adapted. They have to gain the physical strength. So the quarantine is done. In fact, quarantine is done before mission also. 15 days before the mission, Shubhanshu Shukla was put in a isolation facilities, and we could only talk to him with the 25-meter distance. And he will sit on other side, we will sit on other side. So it is said that if for 15 days, any infection which you caught on Earth will either surface or will get cured. So nobody launches an astronaut with any latent infection which is there in the body. Next please. Now all of you are asking, want to become astronaut, how the astronauts are selected. So astronauts are selected based on the physical and psychological tests, and 500 plus tests are conducted in this domain, and there is a very narrow window of acceptance, including, like for example, the minimum height is 150 centimeter, maximum height also is 190 centimeter. You cannot have astronauts taller than that, and because of the accommodation and many other aspects. Then, go back. So in the first batch, we have the Air Force test pilots, not Air Force pilots. So Air Force test pilots are cream among the fighter pilots, and they are the pilots who test the developing vehicle. Like any Tejas is getting developed, the test pilot will test. Any modification in MiG-29 happened, the test pilot will take the risk, and they are trained to handle all non-nominal scenarios. So they are the best choice for first time missions. So that is why in the Gaganyaan, all the 4 astronauts are test pilots. That doesn't mean that all of you should become test pilot. There are opportunities for scientists and other people also. When our program gets evolved, then we have the room for all the disciplines. But in the beginning of program only, this is the constraint. The training is very, very hard. So they go through a generic space flight training, maybe about 1 year. Then the mission specific training, like somebody has to on the Gaganyaan, Shubhanshu went on the Crew Dragon, somebody will go on the Soyuz. So the familiarity with that vehicle is very, very important, because if somebody is driving Toyota, suddenly if I put them in the Maruti, they still struggle to find where is this control, where is that control. So the mission specific training also has to be done. Emergency procedure, they should be very, very conversant. Use of all kind of aids, food, water, how to use that. For that also training is required. Hygiene management training is done. Microgravity experiment, whatever Shubhanshu Shukla did there, for that there was a training done on the ground. Though it is not a microgravity environment on the ground, but still to conduct that, the elaborate training, because it is surprising that, so he is test pilot, he is conducting the biotechnology experiment, he is conducting the experiment which is probably computer science experiment, many other kind of experiments. So one person has to be made all-rounder. So for that, training is the only answer. The spacewalk training is generally done in a big pool, which is an Olympic size pool, and their weight will be offsetted by the buoyancy of the water, and they will feel like they are floating in the space, and all that EVA training is done in that kind of pool. Next please. Now just hold on. Right side you see the Shubhanshu Shukla getting training for the fire suppression. Right side is the EVA training. The left side bottom, it is our simulator. Now Gaganyaan will look like this from the inside. So the 2 of our astronauts, they are getting trained there. They are practicing the mission scenarios inside the module. Right side, when they completed this particular mission scenario, they came out. So these are the 2 astronauts which are with us. Next please. Next. So these are the facilities. These are the primitive facilities which currently ISRO is having, just enough for the mission specific training. We are developing the big campus where all kind of training can be done. The Indian Air Force is helping us in some part of training. Next please. Next. Now pathway to final Gaganyaan mission. As I said that the test program has to be elaborate, design review has to be very, very thorough. So you cannot test directly in the final configuration. So what we do the system piecewise testing. Like crew escape system is tested in the test vehicle mixer on the left side. The parachutes are tested in the airdrop test, where with the helicopter we lift the module, drop it from the 3 kilometer and see if all the parachute deployment events are happening properly or not. Then there will be unmanned flights which is a kind of full dress rehearsal. Then the crewed flight. So this is the pathway for the mission. Next please. Next. So this is the picture of test vehicle D1 first mission. You can see the vehicle lifting off, then getting separated, then parachutes getting deployed, splashdown happens. Now you can see that there the module can tilt. So this was not having uprighting system, otherwise it would have come straight. Then the Indian Navy recovered the whole module. Next please. Now I will show you the airdrop test, the real on 24th August when it happened. So from the Sriharikota, the Chinook helicopter, it lifts this 5-ton module and take it towards the ocean. Now you can see about 3 to 3.2 kilometer altitude it is released. Now crew module is going back. Now you can see the explosions happening, apex cover separation, one parachute pulling other parachute, parachute getting deployed. Now see such a beautiful scene which is captured. And this is the, now the dive will come out so that you can spot the divers coming there, stowing the module, pulling towards the ship. Now this is the Anvesa where Srinivas Rao sir, his concept. So that is the ship we utilized. So now this is coming on the Anvesha deck. Now you see the crew module should not swing too much. So these are not the simple cranes. They are designed to stabilize and recover. Now it is put there. So post recovery, Chairman ISRO visited, team is briefing. So in the actual mission, astronaut will be extracted from here on the ship deck. Then it comes back to us for the next mission. So next mission may happen in another 3-4 weeks.
Mission what is accomplished today.
Next. No, you skip this. Now this I don't want to talk anyway. All of you have already met Shubhanshu Shukla. So XCM4 mission, 18 days. Only one thing important, that in 18 days, he could travel 13.5 million kilometers. Nobody on currently alive who would have traveled in India this much, 13.5 million kilometers. Next please. So this is my last video. This covers the whole Gaganyaan mission profile from the beginning till end. Next. So this is our old space recovery capsule experiment which happened in 2007. Again recovery was done in the similar mode. Then we did the crew module atmospheric re-entry experiment. That also was successful. Then we did a pad abort test where the pad emergency was simulated. So a fast firing rocket taking off the crew module in few seconds in the safe zone. Then the test vehicle D1 mission. So it is lifting off and almost beyond the velocity of sound. The things were done beyond 1 Mach. So these are the training facilities. Centrifuge is one of the things which Shubhanshu showed you. So now this is how the human rating Mark C launch vehicle will be integrated. In the integration bay, the stage will come one by one, and finally the crew module along with the crew escape system will be positioned. Astronauts will move towards the pad about 2 hours before the mission. They will check the health of all the systems, and the crew access arm gets retracted and the lift off happens. Lot of acceleration, lot of G load will come on the chest. The 2 boosters got separated. screw escape system got separated because it is a nominal mission. Then the cryo upper stage is getting fired. Module gets separated, solar panel gets deployed, and then we will be orbiting at around 400 kilometer height at 51.5 degree inclination. And after completing the mission, all the experiments there, the preparation to come back, that will be rotated. The propulsive braking will be done, then the aero braking starts when it moves towards the earth. Again lot of load coming, the parachutes are getting deployed one by one, and then touchdown happening, the recovery team reaching the astronauts, combination of helicopters and boat. The uprighting happened, crew module came, and successful mission accomplished. This is what we are going to do. Thank you. Last slide. One of you has to do this. Our flag on Mars. Who all are ready? Yes. Thank you very much for your attention.